Okay. Bismillah ar-Rahman ar-Rahim. We'll continue this section 2.4. So where is the function continuous? This is what I will discuss. Notice if I have a function continuous and G is another function continuous, then their sum is continuous, their product is continuous, constant times the function, product, difference. If over G provided G of A not equal to 0, so they are continuous. That means if any polynomial is continuous everywhere. For the rational, I need to be worried about whenever it's defined, it will be continuous. So also these functions, they are continuous in their domains. All of these functions are continuous in their domain. So to study the continuity of a function, we need to check what's its domain. So as I said, polynomial, rational, radical, trigonometric, exponential, all of these, they are continuous in their domains. Why we are concerned about that? Because finding the limit, if the function is continuous, then finding the limit is just substituting. Look at this one. X equal minus 2 belongs to the domain of this function. So what's the domain of this function? All real numbers except 5 over 3. So we have no problem with x equal minus 2. So finding the limit is just substituting. Substitute, you have minus 8 plus 8 minus 1 over 5 plus 6. So I'm getting minus 1 over 11. Same idea there. X equal 4 belongs to the domain of f. You have no problem substituting. So I have what? 5 plus 2 over square root of 9. So I have 7 over 3. So it means the polynomials are continuous everywhere. This one, what is the domain of the function? All real numbers except 1. This one is continuous everywhere. So the domain of the function from minus infinity up to infinity. Square root of x, I know the domain of the function from 0 to infinity. So this is the continuity interval. This one, I need sometimes to do some calculation. This one, I need this to be non-negative. Also, I need x not equal to 6. So if I combine this, I have 9. This is less than 9 and not equal to 6. So it is from minus infinity to 6, open, then 6 to 9, closed. Tan x, by the way, sine and cosine, they are continuous everywhere, but tan x, we can deal with it as sine x over cosine x. So my cosine only when cosine equals 0. So the domain of f, cosine x not equal to 0. That's the most important. So that means x not equal to n pi plus pi over 2. So what is the domain? All real numbers except this. Such that n 0 plus or minus 1, any integer. Okay, so that will be the continuity there. Now, if I have a combination of functions, you need to find the domain of each function and then find the intersection. But you have denominator should not equal to 0. So from here, I have ln x. That means x should be positive. Tan inverse of x. I have no restriction because the domain of tan inverse is from minus infinity to infinity. So we have no restriction there. X squared minus 1, also the same thing. But since it's in the denominator, I want this not equal to 0. So what will happen? I have x not equal to minus 1 and x not equal to 1. So I have 0 open and x greater than 0, but x not equal to minus 1, not equal to 1. That will not make a difference. So it will be the domain of f from 0 to 1 open, 1 to infinity open. Okay. If I need to find this problem as x goes to pi, I have no problem here. This is continuous everywhere. This is continuous everywhere. So, but the denominator will not equal to 0. So I just substitute. So pi belongs to the domain of f. So you can just substitute. That will be sine pi over 2 plus cosine pi. That is 0 over 2 minus 1, which is 0. So that will be the limit. Now, if I have function over function, actually, I'm applying these theorems. If f is continuous at b, and the limit of g of x is equal to b, so the limit of this equal to b, and f is continuous at that value, then finding the limit is just by taking the limit inside. That's the theorem which I need to apply. So if I apply it here, so I need to find the limit as this goes to 1 of this function. How to do that? I check it through the rationalizing calculation. That give me what? 1 minus x over 1 minus x, 1 plus the square root of x. This is cancelled, so I'm getting 1 over 2. Okay, so we say the limit equal to b on us. So it's equal to b. So what I need f is continuous at b. F, which is sine inverse, is continuous at half, and that is true. So I can insert the limit. So this one will be equal arc sine. I take the limit inside. With idea, I can do the calculation. That give me arc sine of half, which is pi over 6, 30 degrees. If I want to describe the intervals in which each function is continuous, tan x we did before. This one, I need to check the limit of sine 1 over x. I know this limit does not exist. That means f is not continuous at x equals 0. What about other values? I have no problems. So it's defined, everything is okay. What about this one? We're going to check the limit as it goes to 0 of x sine 1 over x. I can do this by squeeze theorem and get the answer 0. And if you notice, h at 0 is 0. So this is equal h at 0. So that means h is continuous at x equals 0. That means what? H is continuous everywhere. Because the other values I'm not concerned about. So I have this rule. We'll apply it also here, where I can take the limit inside. So this one, number 1, is to do it here. Limit x goes to pi of sine x plus sine x. Take the limit inside, so that will be sine the limit x goes to pi. Sine is continuous everywhere, so just that will be sine. That will be what? Pi plus sine pi. Sine pi is 0. That will be sine pi, which is 0. So the answer is 0. I have no problem with sine. Then just need to be sure that the limit is positive, and it is. So number 2, limit x goes to 1, then x squared minus 1 over x minus 1. I can take the limit inside, so it will be len limit x goes to 1. This is what? X minus 1 times x plus 1 over x minus 1. I can substitute. So you get what? Len, this is cancelled. Len 2. That's it. 3. What is the limit? As goes to minus 1 from right to square root x minus 1. X goes to 1 from right, sorry. Because it cannot be. I can take the limit inside, so that will be 2. Limit x goes to 1 from right, so it makes sense. That will be 2 to the power 0, which is 1. For the same thing with the absolute value, limit x goes to 1 of this function. That will be absolute value of the limit. Take it inside. Since the absolute value is a continuous function, that gives me what? 2 minus 3. absolute value of -1, which is 1. The last one. First x. So this is cancelled. So you have sine inverse of what? If you substitute 0, cancel the x, not the 2. So you have what? 1 over 2, which is pi over 6. Yeah, these are all the exams, questions related to that. So the same thing, the limit n. So you have sine inverse, square root 2. Yeah, take the limit. Yeah, since everything is defined, this is tan 0 is 0, this is cosine 0 is 1, so I have nothing to worry about it. So we just substitute. You have 2 plus cosine 0 over e tan 0 plus cosine 0. That will be the square root of 2 plus 1 over a0 plus 1. So that will be square root of 3 over 2, and that is pi over 3. The sine inverse of square root of 3 pi over 2. The same thing here. It cosine of the limit as goes to 0. But how to find this limit? I need squeeze theorem. So by squeeze theorem, this limit goes to 0. I think we did something similar. So that will be cosine of 0, which is 1. Check. Limit equal to 0 by the squeeze theorem. Yeah, I can take the limit inside. That will be sine limit x goes to 1. X secant square x minus tan square x minus 1. Do the calculation. I have what? Secant square 1, which is just a value, minus tan square 1, which is the value, minus 1. What shall I do? You don't have these things here. You notice 1 plus tan square x, for any x is secant square x, and x where the function is defined, and it's defined here. So secant square 1 is the same 1 plus tan square 1 minus tan square 1 minus 1. So that will be sine. This is cancelled. This is cancelled. Sine 0, which is 0. So this is the answer. The same thing here, but I need great integer things. So that will be cosine pi over 2. Just a constant. I can take it out of this one. If x goes to 3 from left, 2x goes to 6 from left, 2x plus 1 goes to 7 from left. So this would be 6. That will be cosine pi over 2 times 6. And that will be cosine 3 pi. I know 2 pi will not make any effect. That will be cosine pi, which is minus 1. So that will be the answer. This one, I take the limit inside. That will be cosine. Limit theta goes to 0. Pi theta over sine theta. I know this is 1 as the limit as theta goes to 0. So that will be cosine pi, which is minus 1. Same thing. You need to be careful a little bit. If x goes to 0 from left, then 1 over x or minus 1 over x. I can graph minus 1 over x, which is will do something like this. Now it goes to 0 from right. 1 minus, this goes to minus infinity. So tan inverse minus 1 over x will goes to what? Tan inverse, this is the tan inverse. This is pi over 2, this is minus pi over 2. So as this goes to minus infinity, I'm going to what? To minus pi over 2. And that will be my answer. Arc sine, I think we did this. We did this before. Yeah, it's the same as this one. So the answer is pi over 6. Yeah, this is the answer. We need to do it again. This one, I need to rationalize? No, because if we substitute, this function is continuous. This function, continuous, at x equals 64. So I just substitute. It will be 16 minus cube root of 64. And this is 16 minus square root of 64. So it's 16 minus 4 over 16 minus 8. That will be 12 over 8, divided by 4, 2 over 3. That, 3 over 2, sorry. 3 over 2. What a mistake. Okay. Now we'll discuss questions where I need to find the interval where the function is continuous. Okay. I need this to be greater than or equal to 0, and this not equal to 0. So I will do this interval. That means x greater than or equal to minus 3. I need that. So this is minus 3. I want x to be greater than that and not equal to 0. So I have it from minus 3, 0, and 0 to infinity, where it's 0 is open. So this function is continuous where? So I need this to be greater than or equal to 0, and the x not equal to 3. So I need to solve this inequality. Yeah, I need to do it. X plus 4 times x minus 3 greater than or equal to 0. So we'll do it like this, minus 4 and 3. It's just an equality. We'll just solve it. So if x minus 5, I have negative, negative, that will be positive. 0, give me negative, and that give me positive. So I need it to be positive, so the interval which I will take, this is minus 4. I want this, and I want from 3 upward, and it's just the positive things. And I want x not equal to 3. So this is open. So I have the answer for minus infinity, minus 4, or closed. 3, it will be open up to infinity. And that will be my answer. This function will do the same, but need a little bit of calculation. This will do nothing. This is continuous everywhere. I need this not equal to 0, which is what? X minus 8 times x plus 1. And x not equal to minus 1, or x not equal, and x not equal to, and x not equal to 8. And then it needs to be, I need to be careful here. I need x squared minus 4 to be greater than 0, not equal to. So I need to solve this equation, this inequality, put minus 2 and 2, take minus 3, you have positive, negative, positive. So I need the interval. This is open, open minus 2, open 2. So it need to be like this, and this is like this. Okay. So where is minus 1? Minus 1 is here. It's outside my actual interval, but 8 is here. So I have from minus infinity to minus 2, union to 8, union 8 to infinity. And that will be my answer. This one, just I need to do calculation. Yeah, be careful. This one, I need it to be positive. And I know that it will be minus 2, 2. And I need this. We did it before. Also, I need this not equal to 0. So x not equal plus or minus 1. So I plug it. This is minus 2. Actually, it's closed. Yeah. And 2 also included. This is skin like this, and this is like this. I notice minus 1 and 1 in that interval. So my answer is minus infinity to minus 2 closed, 2 to infinity closed. I mean, the minus 2 and 2. Yeah, I need to check this. So I need this to be equal to 0. I need this to be positive. I need x not equal to 1. So that means x less than or equal to 2. Plug it. This is 0. This is 2. I wanted less than 2 and greater than 0, and x not equal to 1. So I have this interval. So it is from 0 to 1. You want 1 union 1, but 2 it will be close. So this is the answer. What is the function? Continuous. So you need x minus 1 to be positive, and I need this not equal to 0. So it means x not equal to 0 and x not equal to 3. So I have this is 1 greater than 1, x greater than 1 here. And I want it not equal to 0. That will not make an effect. Not equal to 3. So it will be from 1 to 3, unit 3 to infinity. So this is will be my answer. Yeah, I need to be sure that this is x positive, and I need a minus x not equal to 0. That means x not equal to a. So I need the positive to be 0, greater than, but I need to exclude the a. So it from 0 to a to infinity. So this is my answer. Yeah, I need to be careful here. Okay. Yeah, because at the piecewise, I need to check each function. This one, where I have problems, I have the denominator of this, x equal 5, x should not equal to 5, and x 4 plus 2x equals 0, not equal to 0. It means x not equal to minus 2. X not equal to minus 2. Now, shall I exclude these two? Be careful. I need this interval, this restriction. This is defined just if x is less than or equal 1. This is outside it, so I cannot, I will not consider. So I'll consider only this point. This is point of discontinuity. So it's in this interval. Now do the same here. I have x not equal to 0, but it's outside this interval, so nothing is here. Am I done? No. I need to check now the jump point, or yeah, this is 1. What will happen at 1? I need to check the limit as this goes to 1 from right. From right, it will be here. So substitute this. It will be half. I can substitute easily. Goes to 1 from left. 6, 5 minus x, 4 plus 2x. You get what? 6 over 4. 4 plus 2, this is 6. That will be 1 over 4. They are not equal to each other. So it means f is discontinuous at x equal 1, 2. So you have 1, 2, you have 1, 2. So this is the number of discontinuity. Okay. Sometimes they complicated the function, like in this one. This was a little bit old exam. So I need this argument to be greater than 0. So I need to do the calculation. 3 minus x, 3 plus x over x plus 1, positive. So I plug it here. I have minus 3, minus 1, and 3. And check. Which interval will be positive. By the way, all of them will be excluded, huh? Because it's greater than 0. The 0, I mean this, yeah. So take a value, minus 4. I have positive, negative, negative, that will be positive. Take a value minus 2, positive, positive, negative, that is negative. Take a 0, positive, 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 that is positive. Take a 4, negative, positive, positive, that will be negative. So I need this and I need this. So it will be from minus infinity to minus 3, union minus 1 to 3. And that will be the answer. Yeah. Now we'll come to these problems. He gave me an interval. Okay, that will make our life easier. I need x squared minus 1 not equal to 0. This is easy to do. Okay. Now I need the argument of ln to be positive. I need the number of discontinuity. Yeah, I need the number of discontinuity. This is to find the continuity. But to find the number of discontinuity, I need to check when this will not be true. Cosine square cannot be negative, but I have discontinuity if cosine square x is equal to 0. Cannot be less than 0, but if it's equal to 0, then I have discontinuity. When cosine squared, that means cosine x equals 0. When cosine x equals 0, I know x equal pi over 2. I need to be careful with this interval. Pi over 2, yeah, if I have 0 and 3 pi, so I need to avoid pi over 2. I need to avoid 3 pi over 2. I need to avoid 5 pi over 2. Then the next one, 7 pi over 2, which is outside the interval. Also, I need to avoid -1 and 1. -1 is here, outside, so I'm not concerned about, because this is outside the interval given. Okay, so no need to worry about it. With 1, where is it? 1 is somewhere here. I need to avoid the 1. So I have 1, 2, 3, 4 points of discontinuity. Yeah. When this, I need the domain of this function to make it very clear. So I need the greatest integer of x minus x. I need to avoid this should not be equal to 0. So you want to avoid when the greatest integer of x not equal to x. When that's true, it's all real numbers except the integer. This is true only if x is, the equality. If x is an integer, the greatest integer of x equal x if x is an integer. So I need to avoid the integers. So all real numbers except the integers, not the positive integers, not the rational. No, this is wrong. Not all real numbers except 0. Okay. Now let me check this one. Yeah. I have 2 more to go. Len of tan square x. Yeah, I think these are too complicated, but let me do it. Okay. I need to be careful here. That is len sine square x over cosine square x. That is my y. So what is the domain of this? Yeah, I need 2 things. I need this to be not equal to 0. This is for sure. And I need this to be not equal to 0 too. Why? Because, yeah, how to explain it? Yes, I need actually these things to be positive. And this is positive, and then negative, So I avoid it to be 0, that's it. So I need also to avoid this to be 0. So this is not equal to 0, this is not equal to 0. So in this interval, where I have these two to be 0, they are actually at 0, pi over 2, cosine is 0, here sine, and then pi, then I will be outside the interval. Actually, I'm starting from here. So this is I will not consider, because this is out. And I have here 11 pi over 10. So it means I need to avoid this, I need to avoid this. So x equal pi over 2 and x equal pi only. This function is continuous where? Be careful. This is 2 plus cosine e to the power x. I know cosine anything is between -1 and 1. So if we add 2, I have 1, 2 plus cosine ax is not equal to 3. So this is always non-negative. Always positive, not only non-negative. Cannot be 0 too. So this line is defined everywhere. Defined for any x. Because this is always greater than, actually it's between 1 and 3. So lane is always defined. So my consent only about this. X squared minus 4 not equal to 0. So I have what? X not equal plus or minus 2. So if I have, yeah, I need to avoid minus 2 and 2. So I have minus infinity minus 2, minus 2. That's it. Yeah, that will finish it. Let me stop this part. Let me stop the recording. Thank you.